Yes. Yes, I can. Yes. All right. Nice to meet you, everyone. This is Sung Jung, and I will introduce today. I will introduce regarding the subject of unmanned systems for environmental data observation. In this unmanned system category, I will introduce mostly about unmanned aerial vehicle and unmanned surface vehicles. Uh, I think Professor Lee already introduced about myself, so I will skip this part. But except I want to introduce myself that I have some experience to do the startup company once, and I'm doing the second startup company at the moment, which is the unmanned system. So what I'm mostly interested in is the all of these three categories. I'm not doing only the theoretical work, but also I'm working mostly on practice and product part to make money, you know. So that's why I'm doing the second startup company at the moment. So as you know, there are a lot of the softwares which the mechanical engineers use. I'm also graduate all my degrees from mechanical engineering department. So I think most of you are very familiar with all of these products. When I'm studying at the graduate school, undergraduate school and graduate school, I didn't study that much regarding the embedded system area. However, I knew that most of the unmanned system is regarding the computer software related work. So I have studied for a long time, for about like over 5 years, to learn how embedded system works. And as you see in the product category, there are some like softwares which you might not familiar with. However, I want to emphasize that when you are in the graduate school program, if you study regarding this area, then it will be very helpful when you go into the company or when you start your own startup company, because only theoretical work and the practice work does not result in the real product, which it will affect the real, people around the world. So this is what we do. If there are people who are studying regarding the unmanned aerial system topic, that you might be familiar with it. So the main purpose of my research goal is surveillance using low altitude, long endurance, vertical takeoff and landing unmanned aerial vehicles. To make it realized, there are a lot of categories which we need to know. So there are many topics, but today I will only introduce the three topics. The first one is small complex environmental sensor for atmospheric environmental detection. So this area is needed to make a complex and a small size of sensor package. The second topic is design and development of hybrid power system. This area is needed to make the unmanned aerial vehicle to fly as long as possible. The third topic is regarding the autonomous path planning technology. So today I will start with the first topic. By the way, since we have about like 50 minutes, since I have 50 minutes of seminar presentation, so if you have any question, you can cut in anytime if you want. I have plenty of time. So I will start with the environmental sensor antenna topic. So the problem is that at the moment, most of the unmanned aerial vehicle companies fly their own unmanned aerial vehicle system under the maximum of 6 kilometer altitude, and the UAV can fly for about 2 hours. Although there are some systems which uses the fuel cell system which can fly over 2 hours, but most of them fly under the 2 hours flight time. Also, the altitude is also a problem. It can reach up to 6 kilometers, but the thing is, since UAV can fly for about 2 hours, if they fly up to 6 kilometers, they should directly land down because of the problem, the landing time issue. So what we are trying to do is we want to cover the undetectionable area between the satellite, which hovers at like over 150 kilometer altitude, and the traditional UAV company. So we are targeting to make our system fly over around 30 kilometer altitude, and the UAV can fly about 6 hours. In this figure, this is captured from another company's introduction video. Also, my startup company is to get data, the atmospheric environmental data, which can cover the undetectionable weather conditions. So if you see here, when you see here, there are some clouds which cannot be detected by the satellite. So we can doing these kind of things by using the low altitude, long endurance UAV. So these are the systems we are currently working on. So there are mainly four UAV unmanned systems. The first one is the multi-copter type UAV. The second one is the USV, unmanned surface vehicle. Third one is the VTOL UAV, vertical takeoff and landing UAV. And the last one is the rocket-based fixed-wing UAV, which can be folded when it connected to the rocket side. The multi-copter UAV is already developed, finished the development, and we already submit the paper regarding this area. And at the moment, our research group is working on this rocket-based fixed-wing UAV. There are many information which I want to deliver in this slide. The main subject is, I already told you that getting environmental data as much as possible and as large area as possible. And also, what I want to emphasize is this video. I think there are some persons who are familiar with this gazebo simulator. When we develop this kind of prototypes, since there are many flight failures occur, we usually work on indoor by using the simulator, especially by using gazebo or air sim. However, the air sim needs some computing power, so that we need to use some like a workstation to make the simulation smooth. So we usually use this gazebo. This gazebo is a tool which can simulate, and it is usually used by the robotics area. Yeah, I will skip the last of this. I think you already saw some information. We usually use this our own the truck or ground control station truck by carrying this ground control station, portable ground control station, and usually see the camera images from the unmanned system because of the emergency situations. In this slide, I want to introduce the results of the multi-copter UAV development. This is the octocopter-based unmanned aerial vehicle, which achieves the environmental weather data, and it can fly up to like 150 meters. And we achieved the wind direction and wind speed, temperature, relative humidity, pressure, and the microdust data. Everything works successfully, and we already finished the development. In this development, what the contribution of this development is that we can control the direction of the multispectral camera and RGB camera by using the gimbal. And to do that, we try to use like a PWM signal and both PWM signal and Mablink signal, and also UART like serial communications. But we ended up by using the PWM, the best, like a basic signal process because of the robustness. I think you already are familiar. There are some students who are familiar with this kind of hardware work. The thing what I want to emphasize is that the most developed, most recent like protocols which we use for the like robotics communication, signal communication, there is not currently very robust that much as the traditional communication method as much. So there are there was some issue. So here you can see the operation of the unmanned multi-copter UAV. And this slide I want to introduce regarding the rocket-based foldable fixed-wing UAV. This is the first prototype, so we didn't try to launch it at the moment until now. We will launch it at the end of this year. We are currently working on the engine parts, and you can see how the solid material-based rocket engine. The maximum thrust of this engine is about 100 Newton, and we estimate that it can carry like 2 to 3 kilograms of the unmanned UAV up to like 150 meters. We already calculated. And this is our goal to achieve environmental data. The previous rocket-based UAV can reach up to like 30 kilogram altitude. So if we fly it like 50 something areas in our country, then I can cover all the area. So what I want to do with this is that I want to achieve all environmental data, three-dimensional environmental data around up to 30 kilograms, and I wanted to sell those environmental weather data to weather related companies. For example, I wanted to sell those data $100 per 1 MB, something like that, so that I can do business work. The second topic is the design and development of hybrid power system. Am I doing okay? Can you hear me very well? Everything's okay? I hope so. Since there are no any sound at all, and okay. Topic: the design and development of hybrid power system is needed since we need to make the UAV fly as long as possible. So basically, what we are trying to do is we are trying to use another energy source for the motor of the UAV. So for example, like a photovoltaic module and the spark capacitor and a fuel cell systems are used to merge the energies for the thrust of the UAV. And these are the 4 prototypes which we have developed so far, and we are working on the 5th prototype for the business launch by our startup company. First one we use Arduino, second one Raspberry Pi 3B version, and this is the NVIDIA Nano, and this is the NVIDIA Jetson TX2. And we tested the performance of this hybrid power system by using charger and discharger, and also by using the constant temperature chamber, and we verified the performance. And this is very small, but it can manage energy, the electric energy is very well. And the other issue what we confronted when we developed this hybrid power system is that since the hybrid power system is not robust at all at the moment, so we cannot fly the very expensive UAV system in outdoors because of the crash issue. So we tried to build indoor stand, like something kind of jig, which can hold up the UAV, and also we can measure the forces which occurring while the UAV, the motors run. So yeah, we make it. So we are currently making this jig. So what we are trying to do is there is a 3-dimensional force sensor at the very this area. So when this VTOL type UAV try to move, we can measure the force data. So I can I can estimate how much this UAV make power. So how much we need to add more additional energies and so on. And also, if you see the upper right figure, there are something inside, and most of these systems is regarding the energy sources. For example, fuel cell system, which requires the small tank. We use a 5-liter tank, carbon tank, which can maintain some kind of hydrogen gases inside, and so on. The third topic which I want to introduce today is regarding autonomous path planning. technology. This autonomous path planning technology, which is the area which I studied for my graduate program. The thing is, although I studied regarding this autonomous path planning technology for a long time, for about like 10 years, and the thing is, I moved from the traditional path planning, theoretical work, which usually uses like a cruise between cruise and Dubin circle for the UAV, and we study the path planning to make the UAV avoid some object or approach to the goal area as soon as possible, something like that. That's the traditional direction of the path planning research area. However, I tried to move this from this traditional direction to the new direction, which considers the energy when we doing the path planning. So until now, I haven't summarized the algorithmic work into the real C code and make it. I couldn't upload it as a firmware to the mission computer. This is called mission computer. I think before I'm talking about this, I need to introduce that how UAV unmanned aerial vehicle work. Unmanned aerial vehicle carries two computers. One computer is called flight controller, and the other one is called mission computer. And we abbreviate that FC and MC. This FC is usually only consider the controlling UAV itself, like how we control, how we manage the attitude of the UAV and so on. The mission computer MC is used for the more higher the work, like I want to analyze the incoming the digital image data, or the multispectral data or hyperspectral data in real time. Then we need some graphic card, and also we need to have some a computer which have higher computing power. So like industry UAV researchers usually use like AIA Jetson series graphic card, or like me, we use a small computer, portable computer. However, in the unmanned autonomous vehicle area uses much heavier and much powerful computers. For example, like Hybr series, NVIDIA Jetson Hybr series, and so on. Because the unmanned autonomous vehicle can carry a lot of the payload, in contrast to UAV. So the thing is, if we for example, I developed this kind of autonomous path planning algorithm work, and I verified this algorithmic work by using something like a MATLAB or Simulink. Then, since my main goal is to make a product, so I need to make the MATLAB M code or Simulink SLX, the Simulink file, into the a C code or Python code and so on, which can be uploaded as a firmware, like object code, to this mission computer. And for example, I'm using like Ubuntu based the OS, so I need to make some the work before make it, this thing is realized. And that's the very hard and difficult part. As I showed you the very first slide, I'm trying to make my theoretical work to be a real product. That's my main research goal. I need to make a business work. So the theoretical work I only use MATLAB and Simulink for simulation verification, which I compatibly, relatively doesn't take that long time. However, when we try to make these things realized into the real product, that's the issue. Takes a lot of time. We need to make as compact as possible everything, like hardware and software. So that's the main my research group issues at the moment. So these are everything which I prepared today, and from now you can start to ask questions regarding everything. Is there any other question? Yes. Usually students don't ask that much questions, but I hope there are some students. The thing is, when I doing the path planning based upon the energy issue, since I have some experience working at the battery industry, I'm considering the battery characteristics, which means I can model the secondary battery as an equivalent circuit model, electrically equivalent circuit model, which uses like five variables, including resistor, capacitors, and so on. So I can model how the secondary battery work. So in the dynamic equation, the dynamic equation of this kind of battery pack is modelized into and the considered in this path planning algorithm. Is that the answer to your question? Okay. So usually the path planning, the researchers do not consider the actual energy source itself. They only consider the like a path, like real physical distance between waypoints. However, if we fly UAV, each UAV system has different characteristics. If I use like a fixing UAV, even in the fixing category with UAV, it has all UAV from different brand has different characteristics, of course. So I'm actually trying to use this kind of dynamic system model into this path planning work, which is not easy that much. Also, I'm trying to make the energy source modeling as well. Yeah, thanks. Yes, I can. Okay, that's a very good question. So originally, I started to use the Raspberry Pi when I started to build this multi-copter based UAV like 3 years ago. However, as you see, there are many sensors in it, and I need to make things to be in real time, make things in real time. And what the issue which I came up when I was using the Raspberry Pi 3B was the system was not very robust. The communication is keep disconnected and so on. So next time I use the NVIDIA Jetson Nano before I need the Jetson TX2. Nano is really a little bit has better computing power compared to the Raspberry Pi, but also didn't work very well regarding the communication. The thing is, I want to see the incoming environmental data in real time in my truck, when I was seated in my truck. So we ended up by using the TX2, which is the most powerful and lightest computers which I can get in the industry. That's the reason. This unit it is composed of two parts. One is JetX2, and also we need a OBT carrier board. In the bottom side of it is that we need carrier to connect with we need to make LAN or UART or USB 3.0, something like that. So total cost is about $1,000 maybe. Marblink is just a communication protocol, so it's like a mandatory protocol. Without Marblink, I cannot talk to the Pixel flight controller. So Marblink is like a basic mandatory part, and I'm using ROS because I didn't explain the details how this multicopter works because of the time. But what I'm trying to do by using this multicopter is I try to make my systems to direct to head to the direction by how do I say, from like 135 degrees from the azimuth of the solar sun all the time. To do that, I need to control the yaw angle of the UAV. So there are some methods how we control the yaw angle of the UAV. But what I approach is I use the off-board mode. I think you know off-board mode, flight mode in the Pixel system. So I use the off-board mode, and I try to give the Marblink signal. Okay. Let me explain easily. So when we use this QGC, Q-Ground Control, users upload the wafers, right? When you upload the wafers, each waypoint contains altitude, longitude, and altitude information. What I try to do is I have into this Marblink signal by overlap the yaw angle of the Marblink the signal by using the Jetson. Can you understand me? Oh yeah, of course, yeah. So that area is like a SLAM area. SLAM is mostly used in the indoors path planning, or indoors like unmanned autonomous operations. And there are many people who are using this kind of system like a Pixel and Jetson TX2, because the SLAM uses a lot of the incoming digital camera images to map inside. So I think yes, it is possible. Yes. Yes, yes. Basically, I use Mablink based ROS, which is MabROS. In the MabROS, when you echo the ROS topic echo, you know that command, right? ROS space echo space like I slash IMU slash something. You can get any data from the pixel. Yes, you can use anything. Yes, and you can reach up to any actuators if you want. But I try to but the thing is, I don't need to like manage at that level because I only need to hack the waypoint information and give more like a yaw angle. That's it. Yeah. Yes, in the manuscript, I even explain the cost, bill of materials in it. It is not published yet, but if you are interested, I can hand it to Professor Lee for your reference later. If you want, I can share the screen here if there are not many questions today. You're welcome. Uh, uh, I'm sorry, excuse me. Professor Lee, could you translate it to me? I cannot understand very well. What is the 8 points? I didn't understand it. Okay. I see. Yes. Okay, go on. Yes. Yes. And this internal engine, can you see me my mouse cursor? Okay. This engine is this part in the video. Okay, like this part, only this part. And this is our in-house customized PCB, which only controls these 3 pins based on PID control method to make the rocket to be straight as much as possible and didn't circle around. And the ejection part, this ejection part, we control from the POD part. It is called POD from the pod, not from the rocket. So basically, if this rocket reaches up to like 30 kilometers, we try to make the rocket to be like how do I say? Make the direction to be like this, and then we try to make the ejection part operate to make the folded fixed-wing vehicles to launch from this. And at the moment, we need to make a maximum PWM signal to operate it as much as possible, as quickly as possible. However, this is just a theoretical concept. We didn't try yet until now. Yeah. You're welcome. Yes, that's another good question. Uh, and I think uh, this kind of question can be asked from the people who didn't have a real outdoor flight experience. The thing is, the fixing vehicles can cover like a long area and fly a long time. The thing is, the launch, how do we launch the fixed wing vehicle is the issue. It has a long, like large area to make it safely launch and safely recover later after the operation. So, yeah. So, however, the our company's goal is to make operate this system around this urban area, not only the outside of the city. So that was the reason. Yeah. Because yeah, yeah. Also, we only succeeded on the several flights of the fixing vehicle, which means every time, most of the I would say over like a 50% of the chance we fail the landing operation. It is very hard to safely land the fixing vehicle. Yes. Yeah. The the handle launch type of the method to fly the fixing vehicle is very easy. However, the landing was the issue. Yes. Yes, just a simulation. Yes. In this video, I want to emphasize I used both USB, which carries the UAV on that. It is very small, but as you see, so what we try to demonstrate is we can use this both UAV and USB system for the environmental data achievement. That's it. Yes. Just the image sensors. That's it. Image sensor. I couldn't like embed these all sensors in it. Yeah. You're welcome. Mm. Thank you very much. Have a nice day. See you.